So on Friday after the quiz, we went through just a little bit of the beginnings of some logarithms. Just like with the exponential stuff, you are allowed to use calculators on some of these problems, most of these problems. There's going to be some that we look at today where I'm going to ask you to do it without a calculator. These are things that you should be able to do in your head, all right? So there's two important logarithms that we didn't talk about on Friday. First one is the common log. You will see this one written as just L-O-G. It will not have a base with it. This one is base 10. Does anybody remember what the other special logarithm is?
It's like ln.
ln, yes, it is the natural logarithm. And it is ln. Do you guys remember what base that is? E. So if you see just log with no little subscript number, it's base 10. If you see ln, it is base e. So I want to write down just a couple exponential form versus logarithmic form to have as examples as we go into these first 8 problems here. So exponential form, if I have 5 to the 0 power, what is 5 to the 0 power? 1. Taking that and writing it in its logarithmic form, we would have log base 5. Then after that, you would have the argument, which is 1. Remember, logarithms are a way to isolate the exponent. So that would be equal to 0. Or if I had something like 2 to the first power, 2 to the first power is what? 2. So if I take that and I write it in its logarithmic form, that would be log base 2 of 2 equals 1. Let's get one more example written down here. If I have x to the power of y equals z, what would that look like written in logarithmic form?
Log of x.
Log base x, and then z equals y. Remember, in logarithmic form, the part that comes after the x or after the equal sign is your exponent. Real quick note about talking about how to type things into Canvas in logarithmic form. So when we're typing things in exponential form, you know how we use that little caret to mean an exponent? So 5 to the power of 0 equals 1 is how we would write it like this. Logarithmic form, you're going to write log, and to indicate that what comes next is the base, you're going to use an underscore, which is shift and then the dash key. And then you would put in your base. To make sure that that is separate from what the argument is, you're going to put the argument inside parentheses. So when you put it in Canvas, the argument has to go inside parentheses. And this is pretty standard notation, just like that caret symbol that gets used on calculators that don't have math print. Anybody that is used to teaching or reading math would be familiar with both of these notations. That underscore is how you would indicate a base on a log in just about every single universal way of doing that. All right, so I'd like to practice taking 1 through 4 and writing them in their exponential form. How would I rewrite number 1 in its exponential form? 4 to the negative second equals 1/16. What about number 2? 7 squared equals 49. Number 3? 2 to the 0 equals 1. And number 4? 3 to the third equals 27. Beautiful. What about number 5 if I want to write it in log form?
Log of 5.
Yep, log base 5 of 125 equals 3. I heard log base 3 and then I didn't hear the rest. And then 9 equals 2. Number 7?
Log of 2. 32 equals 5.
Yep, log base 2 of 32 equals 5. And then that last one. Yes, natural log, so ln y equals x. You do not need to see the base of e on that because natural log indicates that it has a base of e. Awesome. Do you guys have any questions about these 8? All right, down at the bottom of your page, we are going to evaluate these without the use of a calculator. So these first 4, 9 through 12 are at the bottom of your page. 13 and 14 are at the top of the back side. So when I'm answering these, what we're looking for is the exponent. So 2 to what power would give me 1 over 16? -4. So that would evaluate to -4. What about number 10? 2, because we're saying what's the exponent on our base? So 12 to what power equals 144? What is the base on number 11? 10. So 10 to what power would give you 1,000? 3. A trick with your base 10s, count the zeros. Count the zeros. 10 to the first power has 1 0. 10 to the second power, that's 100. That has 2 zeros. 10 to the third power would have 3 zeros. What about number 12? -3. Beautiful. 13 and 14 are at the top of the backside of this. We're going to evaluate these without a calculator, and then we will do the sum or difference. So the first thing I run into is log base 3 of 9. That's 2. So I have 2 plus, and then log base 2 of 8. 3. 2 to the third power gives you 8. Minus log base 4 of 1 over 16. Yes, it's -2. So I've got 2 plus 3 plus 2, which would be what? 7. Number 14. Log base 5 of 5. 1. ln of 1. What are they asking me here?
Natural log of 1.
Natural log of 1. So natural log has a base of what?
E.
So e to what power gives me 1? 0. And then we've got minus log base 5 of 125, 3. Plus, and here's another kind of tricky one, I have natural log again, right? So e to what power gives me the cubed root of e? 1/3, yes. Because remember, we can rewrite roots as fractional powers, e to the 1/3. So this would be 1/3 here. So now I want to simplify this. 1 plus 0 minus 3 plus 1/3.
1 plus 10/3.
1 plus how much?
10/3.
Not 10/3. Close though.
1
1
and 2/3.
and 2/3. Positive or negative?
Negative.
Negative. Negative 1 2/3. You could also express that as an improper fraction. What would that be as an improper fraction? Negative 5/3, yep. If you were typing it into Canvas, an improper fraction would be the better way to type that in, just because in Canvas it's not very easy to differentiate between the whole number component and the fractional component. We are going to skip those two-story problems and all the graphing. So I want you guys to flip forward until you see simplify the following underneath the graph. So it should be underneath the last graph. It says simplify the following. Number 5. I have a base of 5, and then what's my exponent? This whole thing up here is my exponent. So I can think about this almost in its log form. I could say to myself, log base 5 of something is equal to my exponent. What's the exponent here? Log base 5 of x. So what is this mystery something that I have represented with a question mark? X.
How did you eat the log of 5 in the first?
So I'm rewriting it in its log form. Do you remember how on the other page I can take 5 to the 0 power equals 1 and I can rewrite it in log form? That'd be log base 5 of 1 equals 0. And then we were looking at some problems where we had to evaluate without a calculator. Do things like log of 4/16. So it's like, what is that exponent? Well, we would know that that has to be 2, right? Because 4 squared is what gives me 16. So very similar idea here. I'm trying to simplify this or evaluate this. Because it's written in log form, what I'm looking for is the exponent. Or when I write it in log form, sorry. The exponent there has a log, and the argument is x. So I took this thing that looked like this, 5 to the log base 5 of x equals I don't know what, and I rewrote the whole thing in log form. Does that make sense? Mm-hmm. Okay. What I really want you guys to key in on, though, is that when I have an exponential and I have a log, and those bases match, in effect, what happened? They canceled out. They became a 1. I had a base of 5 here, and I had a base of 5 on this log. They canceled each other out, and all I was left with was that x. Let's look at number 2. This one's written in what form? Log form. So I could think about this in its exponential form. 4 to what power would give me 16 to the power of x? Can you guys think of another way that I could write 16? 4 squared. 4 to what power would be equal to 4 squared to the x power?
4 to the power of 2.
Yes. So this would be 4 to the power of 2x. So how would this whole thing simplify then? 2x. I could have rewritten this right here as log base 4 of 4 to the 2x. And now I have this argument and base. 4 to what power gives me 4? 1. And that would just leave me with that 2x. What do you guys think number 3 is going to look like? X. The base and the argument match. 2 to the first power equals 2. What about number 4? X. Base on my exponential is 35. Base on my log is 35. That's going to simplify to just give me X. Before we start on number 5, I want you guys to remind me order of operations. What comes first in order of operations? Parentheses, then exponents, multiplication and division, then addition and subtraction. We take care of logs in this exponents step here. But if there's parentheses, we do our parentheses first. Number 5, do I have parentheses? Yes. How does the natural log of e evaluate? Cancels out, becomes a 1. Because this is saying e to what power gives me e. So that simplifies to a 1. So that's my argument. I still have that natural log on the outside. What is the natural log of 1?
1.
Close.
0.1.
What's the base on the natural log again?
Oh, 0.
Yes, e to what power gives me 1? It's going to be a 0. Look at number 6. How are these parentheses going to simplify? 7. So I have the natural log of 7. Can I simplify it more than that? No, because this is now asking me e to what power gives me 7? I don't know. That's not one that I can do in my head. So I would leave this as the natural log of 7. Ooh, number 7 has a lot of pieces here, doesn't it? How will inside the parentheses simplify? E to the 200. And then I still have that natural log on the outside. Can I simplify that further? What would that give me? 200. E to what power gives me e to the 200. So that simplifies to be 200. Number 8. How do the parentheses simplify? 8. So I have 8 as my argument. Log base 2 on the outside. Log base 2 of 8 is going to simplify to be what? 3. 2 to the third power equals 8. All right. Turn the page over. These were simplifying problems. We are now moving on to solving problems. Very similar process. On number 1, we could look at this 2 different ways and arrive at the same answer. What can you do with number 1? Cancel out the e with the natural log, and that would mean what? X equals 4. Absolutely. The other way that you could have thought through this one is to rewrite this as an exponential. So e to the 4th power equals e to the x power. and then I can see that x would have to be 4. That's another way to think through the problem. So what about number 2? What'd you say? 16. Base of 4, argument of 4. That's going to cancel out because 4 to the first power gives me 4. So I get x equals 16. Just like the other problem, you could say 4 to the 16th power equals 4 to the x power. And then I can see it that way as well, if I rewrite it in its exponential form. Remember, this part, when it's in log form, whatever comes after the equal sign is my exponent. What could I do on number 3? 2 to the negative 3
equals 8 to x.
8 to the x power.
And then you get 1/8 on the left side.
You get 1/8 on the left side.
Equals 8 to the x.
Okay.
And x would be -1.
X would be -1. Is that the only way to think through that problem? No. Can anybody think of another way that we arrive at the exact same answer? Hmm? 2 to the 3rd power. So right here, we could have had 2 to the -3 equals 2 to the 3rd to the x. So 2 to the -3 equals 2 to the 3x. -3 equals 3x. X is -1. That is another way to think through this. Same answer, different mental process. You could have also looked at this right here and said, oh, well, my base is 2. 8 is 2 to the 3rd power. We could have looked at it right there and done that replacement. Log base 2 of 2 to the 3x equals -3. And then picked it up right there. Different ways of going about solving the same problem, all using properties of logs and exponents. Talk to me about number 4. X squared equals 1/4. Square root of both sides. How many answers are we going to end up with? 2. What are those 2 answers? Plus or minus 1/2. I want you guys to flip to the very front page and find what it says about bases, because x is our base here. What has to be true about the base of a logarithm? Has to be positive. Yep. So x is plus or minus 1/2, but in this context, it can only be positive 1/2. So x equals 1/2. Is there any other part of a logarithm that has to be positive? The argument. The base must be positive. The argument must also be a positive. All right, let's do the last 2 on this page, and then we'll flip over and look at the back. How would I go about solving something like number 5? What can I do? put it in natural log form. So I'm going to have the natural log of what? Natural log of 7 is equal to 3x plus 2. What would I do then? I want to get x all by itself. Subtract 2 from both sides. That is not going to turn into the natural log of 5. Natural log is an operation that is happening to our 7. That has to happen first before we can subtract 2 from it. So in my calculator, you guys are going to evaluate this with a calculator in a moment. I would have natural log of 7. Calculators almost always automatically open up parentheses when you put in a log or a natural log. So then you would close your parentheses after the 7 and then do minus 2. Equals 3x. What else do I need to do to isolate the x? Divide by 3. If you do not have a calculator on you, please come grab one of my yellow calculators. So our exact solution is the natural log of 7 minus 2 over 3. We now want to get a decimal approximation by putting that into the calculator. Get a positive or a negative number?
Negative.
Negative. Bigger than 1 or smaller than 1? Smaller. Negative 0.018. If you have a small decimal, give me at least 2 significant figures after the decimal point. All right? Because if it's like 0.00 something, I don't just want your answer to be 0.00. At least 2 significant figures after the zeros end. Number 6. Where would I need to start on number 6? Do I start off as rewriting it as a log? What do I need to do first? Divide by 4 on both sides, yes. That 4 is a coefficient out in front. We got to get rid of that before we can write it in its log form. So I have e to the power of x plus 1 equals 5/4. And now it starts to replicate problem number 5. Tommy, help me out. I'm going to use a natural log because it's base e. What will the argument be? You don't need the calculator for this part. What's the argument on our natural log here? No. Where do you go looking for an argument? Yep, right here. This is the argument. So what am I going to have right after the natural log? 5/4. Equals what, Gavin? X plus 1. Ethan, what do I need to do now to finish getting the x all by itself? Subtract 1 from both sides. So I'm going to have the natural log of 5/4 minus 1. That's what I'm going to put into my calculator. Parentheses get closed after the 5/4. I would like you guys to find the approximate solution. Positive or negative? Negative. Negative what? 0.777 or 0.78 would be fine. Absolutely. All right. Turn your page over. We got 6 more problems to do. What can I do on number 7? 5 squared.
Equals x squared plus 4x plus 4.
Absolutely. We have a quadratic equation here. I always need quadratic equations to be equal to 0. So I'm going to subtract 25 from both sides. So I get 0 equals x squared plus 4x minus what? 21. We're going to factor this guy. X squared plus 4x minus 21 factors to give me what? X minus 3x plus 7? Almost. I like the 3 and the 7. Has to add to give me what?
4.
Positive 4.
She said x minus 3, x plus 7.
Sorry, I heard it backwards. My apologies. I probably even said it exactly the way you said it and still didn't hear it right. X minus 3x plus 7. So what are our values for x then?
3 and negative 7.
3 and negative 7. Where is x in this problem? Now I know what is x, but where is x? X is part of the argument. Tell me about what you know about the argument of a log. Yes. Argument and base must be positive. So I'm going to need to check to make sure that the argument is greater than 0. If I use 3 and I substitute it in the place of x, will I end up with a positive number?
Yes.
Yeah. 3 squared plus 4 times 3 plus 4 is greater than 0. We're good there. What about if I put negative 7 in? Yes. Negative 7 squared would give me 49. Plus 4 times negative 7, I'd have minus 28. That's still a positive. And then I add 4 onto it. So we are good with both of our answers. What happens if I find one that makes my argument negative?
It's not x.
Kick it out. It's extraneous. How do I approach number 8? Caleb, tell me what you notice about both sides of the equal sign on number 8. They're both what? They both have logs. Tell me about the base of both those logs. Both 5. They're the same. So what does that mean about their arguments? They are equal to each other. So I can basically just ignore the log. X minus 2 equals 3x plus 7. So I'm going to end up with -9 equals 2x. So what is x? Negative what?
Negative 4.5.
-4.5, -9/2. Yep, that's okay. -4.5. Do I need to check this? Yes. If x is part of the base or part of the argument, you need to check. If I substitute -4.5 in the place of x, do I have a number that is greater than 0? No, this is less than 0. So what does that mean then? It's extraneous, so what are my solutions? None. No solutions. Number 9. How would I set number 9 up?
X squared equals -3x minus 2.
Yes. Our logs are the same. They're both base 10, so I can ignore them. Where do I go from here? Yep, set it equal to 0. I'm going to add 3x and 2 to both sides. So I have x squared plus 3x plus 2 equals 0. How is this going to factor?
X plus 2 and x plus 1.
X plus 2, x plus 1. So what is x?
-2 and -1.
-2 and -1. Do I need to check these? Yes, I do. In the first log, will I have a problem?
No.
Nope. -2 squared is greater than 0. -1 squared greater than 0. Is x part of the other argument?
Yes.
So I have to go check it there as well. Will I have a problem in the other argument? No. -3 times -2 minus 2. 6 minus 2, that's greater than 0. -3 times -1 minus 2. 3 minus 2 is greater than 0. So we are good on both of those. No extraneous solutions here. Number 10? What can I do on number 10? Natural log. Tommy, this one's coming for you. What is my argument here? 9. Natural log of 9 is equal to what? 2 natural log of x. X is where? It's on the right side. How would you describe what part of the equation it is? Is it a coefficient? Is it an exponent?
It's an exponent.
It's not an exponent.
Is it an argument?
It's an argument. It's an argument of this natural log. What do I need to get rid of to move forward?
The natural log,
I do need to get rid of the natural log. What do I need to get rid of first?
the 2.
The 2. Let's get rid of the 2 first. That's a coefficient. So I have the natural log of 9 divided by 2 equals the natural log of x. Now I can get rid of the natural log by doing what?
Right?
Not dividing. Dividing undoes multiplication. An argument of a log is having a log done to it. What operation undoes logs?
Exponents.
Exponents. I'm going to rewrite this as an exponential now. What's the base on the natural log? So e to the power of this whole thing over here is my exponent. And it's gross looking, but I can put it in my calculator. e to the power of natural log of 9 divided by 2 equals x. What do we get? 3. Comes out a whole lot prettier than you would think. Do I need to check that?
No.
X is part of an argument, right? But it's just x, and 3 is a positive number. Hop down and look at number 11. How would I set this one up?
X plus 10 equals 8 minus x.
Yep, x plus 10 equals 8 minus x. So I'm going to add x to both sides. I'm going to subtract 10 from both sides. 2x equals negative 2. So x is what? Negative 1. Is that a problem with my arguments? What happens when I put it in the first one? Yeah, I get negative 1 plus 10. That's greater than 1, so we're good there. Or sorry, greater than 0. 8 minus negative 1. Yeah, I get 8 plus 1, which is greater than 0, so I'm good. Last one, number 12. Pedro, what can I do with this?
You can set the natural log of 27 equal to x natural log of 3.
Yep, natural log of 27 is equal to x, natural log of 3. Where is x? It's a coefficient. So what's happening between x and the natural log?
Multiplication.
So how do I get x by itself? Now I can divide. X is not the argument. X is a coefficient. I can divide both sides by the natural log of 3. Grab my handy-dandy calculator. Three. Do I need to check this one? Why not? X is positive, but even more so, why not? It's not an argument. It's not a base. It would not matter whether x is positive or negative here because it's not an argument. It's not a base. All right. Your homework over 5-4 is due tomorrow night. Tomorrow we're going to start 5-5. I apologize in advance, guys. I will not be here tomorrow. I have to take my daughter to the doctor. There will be a video over 5-5. On Wednesday, I will be here to answer any other questions you guys have about 5-5. The quiz over 5-4 and 5-5 will be on Thursday, so you'll have a chance to talk with me and ask me any questions that you still have before you take the quiz over 5-4 and 5-5. Have a fantastic rest of your day, guys.